Hey guys, it's Max. This is my circuit that I have been working on this quarter for 320. What this is, it's a guitar pedal. It has 3 op amps, and it uses those op amps and also the diodes to take in a guitar signal, clip it, distort it in a pleasing way, and then it'll output the distorted guitar signal into a guitar amp to be heard and played through. I own a couple guitar fuzz pedals. Many guitarists use fuzz pedals, but this specific circuit is not designed by me, designed by this guy. I think his first name is Eric. It's right here, actually. Let's take a peek. Eric Vincent. So you can actually buy the PCB, just the PCB. It's from Australia. So here he documents it. So why is it called a punk and pie? It's kind of like a play on words in a couple ways. There's a really famous guitar pedal called the Big Muff Pie. It's been around since like the 70s. Yeah, Jimi Hendrix has played it. David Gilmour with Pink Floyd has played it. And famously, the Smashing Pumpkins' Billy Corgan played it. But he had a really this is him, by the way. He had a really specific kind that used op amps specifically. The original Big Muff uses transistors, not op amps for amplification. So this is like the first thought in my head at the beginning of the quarter. I want to build the Smashing Pumpkins fuzz pedal because it is specifically an op amp fuzz. And actually, they've actually remade this pedal, and there it is. It says op amp because it is a fuzz pedal that uses op amps, which is quite special. Anyway, so my circuit doesn't work, obviously. So there's supposed to be 3 potentiometers. One is here. I have 2 connectors. One of the problems already is that one of them is reversed for some reason. I chose I have a poor choice for connectors. So I had to, as you can see here, use micro wire and attach it straight to the PCB, which is super not ideal because these tiny connectors, there's a lot of chance for the solder to just overlap into a different receptacle terminal guy. That actually is a big blob of solder because in my current circuit, which is also wrong, surprise, actually they're supposed to be connected across, so that was very tricky to get those 2 terminals connected but not connected to any of the other ones. Yeah, but these 3 knobs, potentiometers, would equate to the 3 knobs on this guitar pedal here, and they're just controlling various effects of the sound, such as the volume, like the tone, which is kind of like a couple LPFs and HPFs wired together, and like you can vary the potentiometer's resistance to change the combination. Yeah, sustain's a little bit harder to explain. Anyway, so let's talk a little bit more about the circuit. So, and I can talk about where things went wrong and stuff. So there's 3 op amps, the input stage right here, the gain stage where the signal is amplified from a guitar level signal to a signal that can actually be worked with. And then this is the clipping stage with the last op amp. The clipping stage utilizes the diodes to distort the incoming wave. Diodes, as we know, like if we raise, they can clamp down the voltage, the incoming voltage when going through this series of this is a pretty interesting circuit element. I think even in audio, it's pretty interesting already because the entire point of a distortion fuzz pedal is to distort the audio, which is not what we want, usually in audio. So yeah, that's that guy. What else should I talk about? Oh yes, so one of the problems that I had actually, Tina is talking about, you want to identify problems and you want to test as early on as possible to catch your design mistake as early on as possible. this project, I'm working alone, and it's it's been a busy quarter. Like I just didn't have the time to do proper testing, so I actually I sent the bombs, I sent the PCB file, the Gerber files, the drill files, without testing my circuit in KiCad. And I heard, like, as Tina called it, like, it's a Hail Mary essentially. I think there was a lot of us that did that, but I only caught this when I was soldering this potentiometer on like 3 days ago, when my circuit, all my elements have been put on, and like, I spent so much time on this. That was when I caught the mistake, which, if we're talking about lessons learned, simulate your circuit, I guess, before you send it off. I mean, at that point, I already knew that there was going to be problems. I already accepted that it's likely my circuit won't work. But anyway, yeah, in hindsight, if you want to build something that works, simulate it. My problem, it was a simple wire miswiring, I guess. This guy was supposed to be like this, and then this was supposed to be gone. So what I was doing here, I whiteboarded it out like right here. So as you can see, let me zoom out a little bit here. So this is the potentiometer, and potentiometers have 3 terminals. Yeah, terminals is probably a good way of saying it. Like, as they correspond to terminals here on this guy. Zoom, focus. Aha. So what I had was that this is what the circuit was configured as first. We're coming out of the gain stage here, the op amp outputs, and then it's supposed to go to the clipping stage like this. This was not connected, and instead the clipping stage was connected directly to here. So this potentiometer didn't have like the really essential middle thing that sweeps across the little fan blade thing. Actually, the clipping stage should have been connected to here. So it should have been like this. Like that. I didn't do a good job. Like that. That way, the potentiometer is like in parallel here, and then the output comes from here into the clipping stage. Now, yes, I could have technically attempted to scrape the trace of my PCB and jump from identify the point in the PCB that I would need to jump onto the terminal number 2 right there. But that probably, the success rate of that is probably very low, and it's finals week. I mean, there's just no time to spend more time on this project for me personally. So that was like the fatal error that halted me in my tracks. I would need to reorder the PCBs with this, and I would likely retest the entire thing. Again, this is not my design. I'm basing this off of a design available on the internet. So theoretically, all of the design flaws should be ironed out by someone that's not me. But I guess the part that the role that we're playing here in this class is kind of like that of a junior engineer, where you simply implement an existing design. And this is the first time I've done it. I guess things I can do better is test it anyway. Test it anyway, even though it's not a design that you did. Just make sure that it simulates and gives the correct inputs and outputs. Yeah, I don't think there was anything else that was super wrong. I guess the main thing is I guess I could have spent more time selecting footprints. This is one of my favorite ones, by the way. Favorite fuck-ups. Oh, shit. Probably shouldn't be swearing on camera. Anyway, sorry. The footprints for C5 and C4, they're both the same footprint. And I was basing off the assumption that I would have electrolytic capacitors for both C5 and C4, but there was only a film one available for C5, and there wasn't electrolytics for C4. So it just looks really funny like that. I thought it was funny. One thing that I can do to solve that is like get the parts before you choose the footprint, which in my opinion, we should have been doing, like, that should have been a requirement. Like, we should have had our parts ideally in a breadboard, because just simulating in KiCad is not, in my opinion, sufficient testing. I mean, we even talked about at the beginning of the quarter, like, the different substrates. Yeah, substrates. One is digital modeling and software, but another one is breadboarding, you know. Like, all my components are through hole. I don't know about you guys. SMDs are probably going to be harder to do that. And yeah, it's true. Like, you know, this project was designed to, you would have to wait for your parts to come through DigiKey. So I guess that kind of makes the breadboarding step a little bit more difficult because we would have to introduce another step before we putting our components onto the PCB. But yeah, that's my project. I really want this to work one day. I know that I'll have to at least reorder the PCBs, so this could be, I don't know, a year, 2 year, 3 year in my future. But I have all the parts, and it's kind of like a why not if I have some time someday. Yeah, I'll do a little. You want to see the back? Here's the back. All right, because I chose mostly through-hole components. It looks very scuffed in the back. You can see my connectors, a lot of junk and burnt stuff by the connectors. That took me hours. Yeah, I didn't clip the diodes because I kind of thought that this circuit might not work anyway, and I should, you know, repurpose them because we don't have these specific diodes available in the parts room. Yeah, as you can see, diodes D1, D2, all of the D6. Those are my clipping diodes. They're close together. That D7 right there actually is a inverse polarity diode. What that does is in part of the inputs section of it, oh wait, wrong place. Not the input section, the power section. Imagine this is the positive terminal of the battery and then the negative terminal of the battery. That D7, it prevents the current from the battery flowing in the opposite direction. Yes, so you need to insert the battery correctly, otherwise it's going to just stop. It's not going to allow it to flow. Yes. It's called an inverse polarity diode. And then, like, we talked about this in class a couple times, but I have several AC coupling capacitors. This C1 right here is an AC coupling capacitor where the incoming guitar signal is, all we care about is the AC component of the signal, not the DC part. So this capacitor is going to couple the AC component of the signal, and the DC component's not going to pass this C1 here. Yep, and let's try to find C1 on this board. Bingo bango. Another thing I tried to do was all my circuit elements in their respective roles I tried to move them close to each other on the PCB. I spent a lot of time making the PCB look pretty. You know, I Googled some PCB through holes and I was like, oh, so that's what it's supposed to look like. Yeah, I wanted it to look professional at the very least because I was 75% sure that it wasn't going to work. Anyway, this is pretty long now, so I'm going to cut it off here. But to those that watched the whole video, thank you very much. You kind of got a glimpse into my aimless rambling. I have been Max, and this has been my guitar pedal project that didn't work. Thank y'all, and I'll see you in the fall.